Okay, in this lesson we're going to look at the topic of salts, and particularly what are salts and the different methods to prepare them. In the previous topic of acids and bases, we have come across the term salts many times. It's essentially the general term to describe the product that's formed when an acid undergoes a reaction or when an alkali undergoes a reaction. So in the context of O-levels, the definition of a salt is the compound that is formed when the hydrogen ion of an acid is replaced by a metal ion or by an ammonium ion. Now at this juncture, let us try to recall some of the common acids that we have learned. An example would be nitric acid. We have sulfuric acid. And we have hydrochloric acid. Now if we were to replace the hydrogen ion or nitric acid with a metal ion, for example silver ion, then we will end up with the salt silver chloride. Similarly, if we were to replace the hydrogen ions on sulfuric acid with a metal ion, for example magnesium ion, we'll end up with the salt magnesium sulfate. And lastly, if we were to replace the hydrogen ion of hydrochloric acid with an ammonium ion, we'll end up with the salt ammonium chloride. So all these compounds that we have established, that we have formed by replacing the hydrogen ion of an acid, they are in general called salts. Now some of these salts are soluble in water and some of these salts are insoluble in water. So how do we know whether a salt is soluble in water or not? There are essentially 5 rules that will allow you to determine whether a salt is soluble in water, meaning it dissolves in water, or is insoluble in water, meaning it doesn't dissolve in water. And here are the 5 rules. Rule number 1: all nitrates are soluble. Alright, so if you see something nitrate is definitely soluble. For example, sodium nitrate is definitely soluble, silver nitrate definitely soluble. The next rule is all group 1 and ammonium salts are soluble. Now this rule is often condensed or simplified into this, that all spar salts are soluble. Spar salts meaning sodium, potassium and ammonium. Alright, so if you see sodium something, potassium something, ammonium something, they are all soluble in water. Now before we go on to the other 3 rules, it's very important to bear in mind that the first 2 rules takes priority over the rest. Meaning if you see a nitrate, you don't even have to consider anything else, it's definitely soluble in water. If you see a sodium something, you don't even have to consider anything else, it's definitely soluble in water. Alright, now rule number 3 would be all chlorides are soluble except for silver and lead. Alright, so silver chloride insoluble in water, lead chloride insoluble in water, all other chlorides are soluble in water. Next, rule number 4, all sulfates are soluble in water except for CBl sulfates. What are CBl sulfates? Calcium sulfate, barium sulfate and lead sulfate. Okay, so when you see calcium sulfate is insoluble in water, barium sulfate insoluble in water, lead sulfate insoluble in water, all other sulfates are soluble in water. And the last rule is all carbonates are insoluble in water except for spar carbonates. Okay, so it's very important now for you to memorize all the 5 rules, to know it by heart before we try it with some examples. Alright, so take a look at the salts on this page and let us try to determine whether they are soluble in water or insoluble in water. For those that are soluble in water, will indicate that it is soluble in water with the state symbol of aqueous, and for those that are insoluble in water, we'll use the state symbol of solid to indicate that they are insoluble in water. Okay, at this point in time, I will encourage you to stop this video, to pause this video and try it on your own before resuming, before I go through the answers with you. Alright, let's take a look at the different salts and determine whether they are soluble or not. For ammonium carbonate, it is a spar salt, it's an ammonium salt, so therefore it's definitely soluble in water. For silver chloride, we need to use the rule of chlorides. All chlorides are soluble in water except for silver and lead. So in this case, silver chloride would be insoluble in water. For barium nitrate, it's a nitrate, so all nitrates are soluble in water. Barium nitrate is soluble in water. For barium sulfate, we need to use the rule on sulfates. All sulfates are soluble in water except for calcium, barium and lead. So barium sulfate is therefore insoluble in water. Sodium sulfate, once again, is a spar salt, so it's definitely soluble in water. And zinc chloride we need to use the rule of chlorides. So all chlorides are soluble in water except for silver and lead. Zinc is not one of them, so it is soluble in water. Okay, now that we have learned to determine whether a salt is soluble in water or not, we will look at how we can prepare them. Now, in the preparation of salts, there are 3 questions to ask. What method do we use? What starting reagents do we add? Or starting reagents meaning what ingredients do we add to prepare a particular salt? And lastly, how to carry out the method, meaning the procedure to prepare the salt. Alright, we'll look at the question one by one. We'll first look at which method to use. Now, there are essentially 3 methods to prepare salts. At this point in time, don't worry too much about what the name of the method means, because we will look into that when we answer the 3rd question, how to carry out the method. Alright, there are essentially 3 methods. First method is called precipitation. Second method is called the excess method. Now, the reason why excess is in open inverted commas is that it's not a real name, meaning if you tell another scientist excess method, he or she may not know what is that. It's just a convenient name, reason being the method involves adding an excess of a particular reagent. And the last method that we'll look at is called titration method. Now, at this point in time, a natural question to ask is, which method do I choose for a particular salt? There are certain rules that you can use to decide which method to use. Now, we have learned that salts can be either soluble or insoluble. For all insoluble salts, it's very straightforward. There's only one method that you can use. It's called precipitation. For all soluble salts, we need to further establish whether it's a spar salt or whether it is not a spar salt or all other soluble salts. Alright, for spar salts, we would make use of the titration method. For non-spar salts, we would have to use the excess method. Okay, once again, before we move on with some practice, it's important for you to remember which method to use based on the solubility of the salts. Now, in this little practice, let us try to once again establish which methods would be suitable for preparing each salt. For the first salt, ammonium carbonate, we have already established that it's a soluble salt. So it's a soluble sparse salt, therefore we need to use the titration method. For silver chloride, is insoluble, so we can use the precipitation method. For barium nitrate, it's a soluble salt, it's a non-sparse salt, so we have to use the excess method. For barium sulfate, it's an insoluble salt, so we need to use the precipitation method. For sodium sulfate, it's a soluble sparse salt, so we need to use the titration method. And lastly, for zinc chloride, it's a soluble salt, it's a non-sparse salt, so we need to use the excess method. Alright, so at this juncture you should be able to decide which method to use when given a particular salt. Now the next question to ask is, for each particular method, what ingredients or what starting material do we need to use to prepare a particular salt? Now for each method there are different recommendations, so we'll look at one method at a time. For the precipitation method, the starting reagents would be 2 solutions containing the ions in the salt to be prepared. Okay, so for example, if I have the insoluble salt silver chloride, alright, I need to mix 2 solutions, one of them containing the silver ion, the other one must contain the chloride ion. Now the key phrase in this sentence is solutions. Solutions meaning the starting reagents, they must be soluble in water. Alright, both starting reagents must be soluble in water. Now if there are no restrictions given in the question, meaning the question didn't state that you need to start with a particular reagent, always use the sodium something and something nitrate. Alright, why do we always use them? Because all sodium salts are soluble and all nitrate salts are soluble, so we know for sure that they are soluble in water. Alright, so in the example of silver chloride, we need to use sodium something, so we can use sodium chloride, and we need to use something nitrate, so we can use silver nitrate. Alright, so essentially by mixing the 2 solutions, sodium chloride and silver nitrate, we'll end up with silver chloride. Alright, so with that in mind, let us try to determine the starting reagents for each of the following insoluble salts to be prepared using the precipitation method. Now for silver chloride, we have already seen we can mix silver nitrate with sodium chloride. So for lead-2 sulfate, we would want to mix lead-2 nitrate with sodium sulfate. Similarly, for barium sulfate, we want to mix barium nitrate with sodium sulfate. And lastly, for copper-2 carbonate, we want to mix copper-2 nitrate with sodium carbonate. So at this point in time, I hope you have gotten the hang of it, of determining the starting reagents required for the precipitation method. Alright, so once again, if the question has no restrictions, always choose the nitrate and the sodium salt that contains the ions of the salt to be prepared. Alright, now before we go on to the next method, it's very important to point out that something nitrate and sodium something is not the only correct answer is not the only correct choice of starting reagents. They are only convenient choices because we know they are definitely soluble. Alright, the bottom line is this: as long as you have two solutions, meaning the two reagents are soluble in water, regardless of whether it's a sodium salt or nitrate salt, it can be used in the precipitation method. What do I mean by that? Let's look at the silver chloride example once again. So in this case, to prepare silver chloride, I can essentially also mix silver nitrate with hydrochloric acid. Right? Why is that so? Because hydrochloric acid is also a solution that contains the chloride ion. So having said that, there are many correct answers or many correct choices of starting reagents that you can use in the precipitation method, but for convenience, it will help greatly to always use the nitrate salt and the sodium salt. Okay, now in the next method, we will look at the excess method. For the excess method, the starting reagents would be an acid plus an excess of an insoluble solid. Alright, so bear in mind that in the excess method, you need to mix an acid with an insoluble solid. Alright, so let's look at some examples now. Now, the salts here are soluble salts. They are non-spar salts, so we have to use the excess method to prepare them. Alright, and we have already established that the starting reagents in the excess method, we need to mix an acid with an insoluble solid. Alright, so let us try to determine the acids to be used to prepare each of the following salts. For zinc sulfate, what acid do you think would be suitable? It would be the sulfuric acid. Right, for magnesium chloride, it will be hydrochloric acid. For copper sulfate, it will be sulfuric acid. And lastly, calcium nitrate, it will be your nitric acid. Alright, next, to know what insoluble solid to use, we need to think about acids. In the previous topic of acids and bases, we have learned the reactions that acids can undergo. Alright, so if you can recall the reactions that acids can undergo, acids can either react with reactive metals, they can react with bases, they can also react with carbonates. So essentially, there are many options that we can think of when trying to determine the insoluble solid to be used. For example, in the case of zinc sulfate, we need to react sulfuric acid with either zinc metal. Alright, we can also react with zinc oxide, which is a base, or we can also react with zinc carbonate, which is a carbonate. Alright, similarly for magnesium chloride, we can react hydrochloric acid with the metal magnesium, we can react with the base magnesium oxide, or we can react with the carbonate magnesium carbonate. Right, now if we were to follow the same rules for copper 2 sulfate and calcium nitrate, we will run into some problems, but let's put that on hold, and we will look at that more later. Now for copper 2 sulfate, we can, again applying the same rules as above, we can react sulfuric acid with the metal copper, we can react with copper oxide, we can react with copper 2 carbonate. And lastly, for calcium nitrate, we can react nitric acid with the metal calcium, we can react with the base calcium oxide, or we can react with calcium carbonate. Now, however, in the reaction of acids, there are certain exceptions that we must be highly sensitive to, and these are the exceptions that in the reaction of acids with metals. Copper is too unreactive to react with acids. Alright, so in the preparation of copper 2 sulfate, we cannot use copper metal as it's too unreactive to react with an acid. Next, there are also metals that are very reactive, so they will react explosively with acids. So an example here would be calcium. Alright, so in the case of calcium nitrate, we cannot react the metal directly with acid as it will catch fire. Right, so these are the two exceptions that I've mentioned earlier. Copper cannot react with sulfuric acid because it's too unreactive. This is a often tested concept in MCQs, so you need to be highly sensitive of that. Next is that calcium is too reactive, so when it reacts with an acid, it can be explosive, it will catch fire. It's not a suitable method for preparing calcium nitrate. Alright, so having said that, the most universal solid that you can use when determining the reagents for the excess method would be the carbonates. Alright, because acids react with all carbonates. So once again, if there are no restrictions in the question, always choose a carbonate for your insoluble acid. For your insoluble solid. Alright. Now the last method that we'll look at is the titration method. For the titration method, the starting reagents would be an acid plus an alkali. Alright. Once again, if you think about the topic of acids and bases, we have learned that alkalis are your soluble bases, and some common examples of alkalis would be your sodium hydroxide, your potassium hydroxide, which are strong alkalis, and the classic example of a weak alkali, which is your aqueous ammonia. Alright, now bearing in mind that the starting reagents for titration method requires an acid and alkali, let us now establish the acid and alkali to be used to prepare each of the following spar salt. Alright, the acid used to prepare sodium chloride would be hydrochloric acid. The acid for preparation of sodium nitrate would be nitric acid. Potassium sulfate, sulfuric acid, and ammonium sulfate, also sulfuric acid. Alright, now the alkali to prepare sodium chloride would therefore be sodium hydroxide. The alkali to prepare sodium nitrate, also sodium hydroxide. For potassium sulfate, potassium hydroxide, and for ammonium sulfate is actually your aqueous ammonia. Alright, many students would arrive at the answer ammonium hydroxide for this. Alright, however, ammonium hydroxide is not encouraged, reason being it doesn't really exist. Alright, in aqueous ammonia, majority of the ammonia actually remains as ammonia, as aqueous ammonia, rather than ammonium hydroxide. Alright, so in the context of O levels, we would discourage the use of ammonium hydroxide. Now at this point in time, you should be able to do two things. When given a salt, you should be able to determine which method to use. Alright, and you should be able to determine or decide the starting reagents to add to prepare the salt in question. In the next lesson, we'll look at how to carry out each method, meaning the procedure involved for each method.